In this experiment, two processes were compared to see which was more efficient in separating ethanol from water. We have the simple distillation, which is as the picture above, and then we have the fractional distillation, which is the picture below. And the difference between them two is that the fractional distillation apparatus consists of the distilling column. Within the distilling column, it has the gel beads. The unknown I received is unknown number 3. The percent composition will be determined based off the graph that will be shown later in the slides. According to Bell et al., simple and the fractional distillation is the separation of two miscible liquids. We will now talk about the structures of the molecules of ethanol and water. Both ethanol and water are very polar molecules. Because they are polar molecules, they are able to mix and are miscible. The intermolecular forces of water is a lot stronger than the intermolecular forces of ethanol. Therefore, the boiling temperature of ethanol is lower than that of water. Ethanol boils at 78 degrees Celsius, whereas water boils at 100 degrees Celsius. This difference in the intermolecular forces and their boiling temperatures will enable the compounds to be separated from each other when distilling them. Because both water and ethanol are polar and they are miscible, the boiling points are used to separate ethanol and water. The boiling point of ethanol is 78 degrees Celsius, whereas I mentioned earlier the boiling point of water is 100 degrees Celsius. As a result, ethanol is more volatile and will completely evaporate before water does. Water is constantly evaporating, but it's not always at its boiling point. Therefore, while ethanol travels up the distillation head and into the water-jacketed condenser, the ethanol becomes to condense and can be collected as a distillate, whereas the water starts condensing as it reaches up the flask, and it starts to drip down as it's visible in the image above. Therefore, the water goes back into the liquid, but ethanol is able to travel out and be collected at the end. However, because there's not much surface area to work with, water is still evaporating. The distillate is slightly a mixture of that of ethanol and water. As it will be explained later, why in fractional distillation we are able to get a richer compound of ethanol in our distillate and not as much water. In order for this distillation to work, they have to have different boiling points, and one of the compounds must be more volatile than the other. If one of them wasn't as volatile, or if they were just as volatile, they wouldn't be able to be separated because they would both be evaporating at about the same time if they had also the same boiling points. These differences are what allow the ethanol and the water to be separated and allow this distillation to work. As I mentioned before, the distilling column has the gel beads, and what that does is increases the surface area. This provides a larger range where the ethanol can continue to evaporate, whereas water is able to condense within the gel beads, outside of the gel beads, and drops back down into the Erlenmeyer flask. This provides us with a more richer distillate of ethanol. When using the simple distillation apparatus, water is constantly evaporating. So because there is less surface area, water is still being collected in the ethanol distillate. That's where the difference lies, where the fractional distillation apparatus provides more surface area in order for ethanol to continue evaporating, whereas water is able to condense back into the Erlenmeyer flask and provides a richer distillate of ethanol. In this graph, it is very visible how the simple distillation line is very gradual, and it's a little bit harder to tell the percent composition of ethanol and water in the unknown. However, in the fractional distillation, the line is a lot more spread out. Based on this line, at about 7.5 mils of the distillate is ethanol because of the drastic change in temperature. The distillate was being collected at about 75 degrees Celsius and onwards to like less than 80 degrees Celsius, and it was more consistent. But when you start to get closer to an 8 mLs, the 8 milliliters, you start to see that there's a very drastic change in temperature. It goes from like 80 all the way up to like the 90s and stays consistent before reaching the hundreds. And when it reaches about almost close to 100, that's where we know that the distillate being collected is now water. Because of this drastic change, we can then conclude that the distillate being collected about 75 through like less than 80 degrees Celsius is purely or is richer in the compound A, which is ethanol, and has less of that compound B, which is water. According to Bell et al., azeotrope is a constant boiling mixture, which is seen where the distillate is not purely ethanol. Like in simple distillation, there is no large separation of the components. However, in fractional distillation, as most of the pure ethanol is collected, we then have our azeotrope, where the composition is just of water and ethanol until it becomes pure water. The percent composition of alcohol is calculated from the volume of the raise of temperature divided by the total volume times 100. Therefore, the percent of ethanol seems to be about 7.5 mils divided by 20 mils times 100, which gives us 37.5% ethanol. Therefore, the percent composition of unknown number 3 consists of 37.5% ethanol and 62.5% water. As I mentioned before, this was determined by the percent composition calculation, which was used by the change in temperature from fractional distillation, because in simple distillation, it was less of a drastic change in temperature, so it was a little bit harder to see where the percent composition of ethanol ended, or ethanol ended and water began. In conclusion, based off the graph, fractional distillation is more efficient at separating ethanol from water because there is a distinct change in temperature once it reaches about 7.5 mils of the distillate. Therefore, the unknown number 3 consists of 37.5% ethanol and 62.5% water.